Okay, so at the beginning you can just look at the format of exam again. So we have the paper 1, which is the objective questions. Okay, so you have 40 objective questions, and paper 2 we have subjective questions and essay questions. So subjective and essay question, and paper 3 is just the practical test, practicals. So it is experiments. Okay, now we look at chapter 1, introduction to chemistry. Okay, so all these are the introduction, so that means they want you to know about chemistry only. Okay, so let's see at the beginning, meaning of chemistry. Okay, so let's see here. Chemistry is a field of science that studies the structures, properties, composition, and interaction between matters. Okay, so that means you are going to find out, for example, you have, let's say you have a piece of, let's say maybe protein. Okay, protein in your body, so you want to find out the structures of protein. So protein is made of what atoms or what elements, so you want to find out. Okay, so for example, it is made of carbon, hydrogen, oxygen, nitrogen, or maybe sulfur. Okay, so we want to find out the structures, the properties. So for example, we want to check whether protein can dissolve in water or not. Composition is like how many the percentage, maybe the percentage of carbon, the percentage of hydrogen, the percentage of oxygen in protein, for example. Interactions between metals, so we can check whether there is any chemical bonds between proteins and water, chemical bonds between protein and any organic solvent. So we can check that. That is chemistry. So we learn chemistry, that means we will learn something like this. Yeah. Knowledge in chemistry is very important for us to understand chemicals and chemical reaction around us. Okay, so chemical is the thing that reacts. Okay, we call it chemicals. Chemical reactions, of course, like for example, like acid and base react through a chemical reaction that is called neutralization. Okay, something like that. Chemicals in daily life, all substances around us are made up of chemicals. Okay, so for example, our air is made up of chemicals also, we can call that chemicals. So oxygens, nitrogens, carbon dioxide, so you can call them substances or you can call them chemicals. So table 1.1 shows the commonly used chemicals in daily life. Okay, now you can take a look on this table. Okay, so in chemistry, there are 4 important fields. So food such as cakes and ice cream contains coloring, preservative, flavoring, antioxidants, and stabilizers. So these are the chemicals in the food. Okay, so you put all this chemical in the food to make it looks better, to make it last longer, to make it taste better. This one to make it last longer also, to avoid the oxidations of bacteria. Stabilizer is to make the substance mix around properly. Okay, so for example, in peanut butter they put stabilizer so that the oil and the peanut mix well. Okay, so medicines, examples of medicines are antiseptics, analgesics like antibiotic, paracetamol, and aspirin. Chemotherapy is a treatment for cancer patients. So from here you can see in terms of medicines, right, chemistry is related to antiseptic. That means something that can avoid bacteria, okay, can avoid ourselves from bacteria. Analgesics is like, to avoid ourselves from feeling pain. So paracetamol is the example of analgesics. Okay, so you eat this and then you don't have headache. Aspirin, same functions. Okay, so this is the stronger one compared to paracetamol. Agriculture, chemicals such as pesticide, herbicides, fungicides, fertilizers, and hormones are used in agriculture. Okay, so pesticide to kill insects, herbicides to kill grass that we don't want. You want to grow certain plants but you don't want the grass, so we kill the herbicides. Fungicides to kill fungi. Fungi is like, for example, mushroom. Okay, we don't want those mushroom that we don't want, so we kill it. Fertilizer, I think you put fertilizer on the plants, then the plant grow well. Okay, so hormones, so you put hormones into agriculture also, sometimes. In industry, the products of industry include glasses, ceramics, paints, polymers. So the polymers here is like, for example, plastic, detergents. This is to wash clothes. Alloy means they mix the different metals, coloring, and soap. Okay, so these are the examples of chemicals in industry. Okay, now let's see the next part. The developments in chemistry, field, and the contributions of chemical technology. Knowledge in chemistry is required to solve problems in various chemicals fields such as forensic. Forensic is the people that study the dead body. Okay, so forensic. Biochemistry, geology. Biochemistry, for example, people that involved in the study of blood. Okay, so biochemistry. Geology is to study different stones, for example. Okay, so number 2, industry based on chemical knowledge have contributed greatly to the country's developments in terms of its contribution to the economy. Okay, so you imagine why economy, because chemistry make because of chemistry, so we have factory. So if you have factory, then the government can collect tax, so the government become rich. So economy. Creation of job opportunities, they have workers in the factory. Advancement in the industrial sector, so the industrial sector become better because of chemical technology. Okay, so let's move on. Okay, like what I told you, all these are like introduction only. They give you more general knowledge on chemistry. Okay, so let's see this. The export of industrial chemicals such as pesticides is a lucrative source of income for our country. So that means we export pesticides, we export all kind of chemicals, and then we get money. Our country get money. The chemical industry provides many job opportunities to locals. Okay, so the factory worker, the chemist in the factory, the products of the chemical industry provide raw material for other industries. This allows many other industries such as shipping, manufacturing, and heavy machinery industry to develop. So for example, you imagine we use chemical technology to change the rubber into tire, and because of the production of tire, then we can make car. Okay, so that kind of interrelation between chemical industry and heavy machinery, for example. Careers related to chemistry. Most careers require chemistry knowledge. Huh? So that's why we have to say that if you study science, then you have to study chemistry. So because chemistry is the center of science. Okay, so no matter you are more to biology, like you are planning to become doctor, you still need chemistry knowledge, or you are more to physics, where you plan to become engineer, you still need chemistry knowledge. So it's like the center. Okay, so now let's move on. Number 2, the following shows examples of chemistry related careers in various fields. Cosmetic is makeup, so the woman want to make up, and then cosmetic chemist and cosmetic consultant. So you can advise people, okay, what to put on your face, to make you look young, that kind of thing. Pharmaceuticals, pharmacy, medicines. So doctor, biochemist, and pharmacist. So doctor, you should know lah, doctor to treat patient that are sick. Biochemist is more to the blood, the study of blood, to check what kind of virus in the blood. Biochemist. Pharmacist is to prepare drugs, okay, or medicines for the patients. Biotechnology researcher, and biomedical engineer. So biotechnology researchers is like, for example, you use science knowledge to make the tree or the plants grow faster and get fruits quickly without insects that destroy the fruit. Okay, so we can use some biotechnology. Biomedical engineer is more to the machine in the hospital. So for example, like the x-ray machine, the ultrasound machine. So biomedical engineer. Okay, now let's move on. Nanotechnology, part D. So nanotechnology, when I say nano, that means it's very small. Nanotechnology. So nanotechnology engineer. So let's say, for example, you use the virus or the bacteria to produce vaccine. So nanotechnology. Okay, so or you use vitamins, okay, which is, vitamins or maybe some minerals, they are very small. Okay, so you make certain supplement and make the absorptions to be easier for kids. So nanotechnology, for example. Food scientist is the one that involve themselves in food. So to create food that lasts longer, for example, or to create food that is tastier or more nutrients. Okay, green technology engineer and green technology chemist. So green technology, that means it's not green color, it's just that it is environment friendly. So for example, you create plastic bag that will decompose after a few months. So we don't want plastic that lasts all the time. So it is not good for the environment. So green technology. Or maybe we produce smoke without harmful gases. So the smoke from the industry, you clean it. Okay, so by using some technology. Okay, science teacher teach chemistry in school. So that is another career. So become a chemistry teacher. Okay, so in college and in university. Okay, so now you know already. After hearing all this, I study chemistry, then what kind of job I can involve in, okay, for chemistry. So many kind of jobs. Okay, now 1.2, scientific investigation in chemistry. So it is a little bit different compared to physics. Physics, it involves graph a lot, where there's a increase linearly or inversely proportional or directly proportional. We study relationship between variables. That is more for physics. But in chemistry, it is chemical reactions. So let's see. Number 1, the scientific method is a systematic method used by scientists or researchers to solve problems related to science. Okay, let's see what are the scientific method is given here in the table. Diagram 1.2 shows the general steps used to solve a problem using the scientific method. Okay, so let's see. Okay, first, making observations. So let's say, for example, you get a piece of stone from the ground, from the earth, and you don't know what stone is this, or maybe I should say what element is this. So you want to know. Okay, you just get a piece of stone. It looks like maybe you feel like, oh, this one maybe is a very valuable, can sell for a lot of money. Okay, so then we want to find out what kind of stone is this. So first you look at the stone. We call it making observation. You look at it. Okay, so it involves the 5 senses. You look at it, you try to hear, maybe you shake and you hear, taste depends. I guess stone a bit hard to taste it, so don't taste the stone. Okay, you smell still okay lah, no? Okay, so it's more for others lah, no, not for stone. So okay, so touch important. You touch are used to gather information about an object or a phenomenon. Okay, so for example, for a stone, you can look at their color, you can touch to see whether they are rough, they are smooth, so making an inference. Inference is like, okay, you try to guess what is that. Okay, for example, you look at the stone, it is green color, you feel like, oh, is it jade? Okay, jade. So your inference, okay, it maybe it is a jade. Okay, so maybe only lah. So data collected and past experiences are used to make an early conclusion to explain the event. So early conclusion, that means you guess it is a jade. Okay, or you guess the stone is a diamond, so but you don't know yet, so it's just inference. Okay, so we want to confirm whether it is diamond or not. So let's see what to do. Identifying the problem. The problem is identified by asking questions based on the inference made. Okay, so if you say it is a diamond, then you have to ask yourself a few questions to confirm. Is it hard? Diamond is the hardest substance on the earth. Okay, so is it hard? So you try to use diamond to knock other things. Okay, so you have to ask a few questions. Is it soluble in water? So diamond is insoluble in water, so we have to ask some questions and then you have to find out. Okay, so making a hypothesis. Okay, forming a general statement on the relationship between a manipulated variable and a responding variable to explain an event or a phenomenon. The hypothesis can be tested via experiments or investigation to prove its validity. Okay, so you have to set up your manipulated variable and your responding variable, and then you do experiment to see the relationship. So in physics you have this. we have this, which is very important. So you want to, for example, you want to check the relationship between speed and time, so you want to check that, so you can do experiment to determine. But for our example just now, a piece of stone, so this is a little bit hard to put it in that way, okay? But from physics you already understand what is hypothesis. Okay, now identifying the variables, so you have manipulated variables and responding variables. Okay, so now what kind of variables we have? 3 types of variables which can be identified are manipulated variable, responding variable, and fixed variable. Okay, so for example, manipulated variable, let's say I set my experiment, okay, temperature is my manipulated variable. I heat up the stone to 200 degrees Celsius, and then 400 degrees Celsius, 600 degrees Celsius. I want to see their melting point, for example. Responding variable, so I want to see whether it melts or not. Okay, so fixed variable must be the same mass of stone, for example. Okay, so controlling the variables in a scientific investigation, one variable is manipulated, for example temperature, to study its relationship with a responding variable. Okay, the responding variable is you want to see whether gas coming out or not, okay, at different temperature. So at the same time, other variables are fixed. Okay, so planning and experiments, material and apparatus to be used. So for example, the material is the stone that you found. Apparatus, okay, you have to heat it up. You have to heat it up in a crucible, for example. That's the apparatus. Procedure of the experiments. That means the steps. So you have to put them in a crucible. You heat it up, then you check whether gas come out or not. If gas come out, then you have to check what kind of gas is that. So for example, method of collecting data. So you collect data in a table, okay, so way to analyze, so maybe you draw a graph, interpret the data, okay, so you check the graph and then you have to determine the relationship between this and that. Okay, so collecting data, the data from observations or measurement is recorded systematically. So you observe, you tell the color, you heat it up, you tell the gas, you test what kind of gas is released. Okay, data collected can include the quantity of a chemicals, the length of an item, the time taken, so the time taken for, let's say the time taken for the gas to release, for example, other measurements, or in the form of a statement. So like you check the density of the stone, you put them in water, see sink or float, so you can do that kind of experiment. Interpreting data, the data collected is organized and interpreted through graph, charts or calculations to determine the relationship between the variables. So you draw the graph, you draw the chart, you show calculation. Okay, so let's move on. Making a conclusion. A conclusion is made in the form of a statement on the outcome of the experiment based on the hypothesis. Okay, so maybe your hypothesis is the higher the temperature, the more gas is released from the stone, and that's your hypothesis. Okay, then the conclusion is you see whether your hypothesis is true or not. Okay, so maybe you realize it's not true. You heat it up, no gas come out. Then you just say the hypothesis is not true. Okay, so where the higher the temperature, the amount of gas that release is not increasing. So conclusion is to answer the hypothesis. The hypothesis made is either accepted or rejected. So you say the hypothesis is hence rejected. So if it's not true. Preparing a report. All aspects of the experiments are communicated in details to advance the developments of chemistry knowledge. So you just write down all the information. Then for futures, for maybe your report will be studied by other chemists. Okay, so that is for university level. Okay, now let's see experiment. Effect of temperature on the solubility of salt in water. So this is a simple experiment. You put salt in water, you heat up the water, and you see whether it dissolves better or not. Okay, so the aim to study the effect of temperature on the solubility of salt in water. So what format is this? Okay, try to see it in this way. To study the effect of manipulated variable on the responding variable. So in general it's like that. Okay. Problem statement, that means you have to ask a question. Problem statement is a question. Does the temperature of water affect the solubility of salt in water? Okay, problem statement, general format. Does MV affect RV? Hypothesis, an increase in the temperature of water will increase the solubility of salt in water. So you just say the higher or lower the MV, the higher or lower the RV. Okay, now variables. Manipulated variable, temperature of the water. Responding variable, solubility of salt in water. Fixed variable, volume of water, mass of salt, and the time. Okay, so these are the variables. Material, water and salt. Okay, so apparatus. You see material is more to chemicals. So the chemicals are materials. Apparatus are not chemicals, or they are things. Okay, so for example, beaker, thermometer, measuring cylinder, electronic scale. Electronic scale is to check the mass. Wire gauze, tripod stand, Bunsen burner, stopwatch. So you want to find out how long it takes to dissolve, so that's why we need stopwatch. Okay, procedure, the steps. 50 cm cubes of water is measured using a measuring cylinder and poured into a beaker. Using a thermometer, the initial water temperature 30 degrees Celsius is recorded. Using an electronic scale, 5 grams of salt are added in the beaker and stir with the thermometer. At the same time, the stopwatch is started and the time taken for all the salt to dissolve in water is recorded. Step 1 to 4 are repeated with same volume of water and the amount of salt, but the water is heated to a temperature of 80 degrees Celsius. So you change the temperature. Okay, then let's see the pictures. So we do our experiment in two different temperatures, 30 degrees Celsius and 80 degrees Celsius. So you have to check how long it takes to dissolve. Okay, so the time taken for all salts dissolved at different temperatures are recorded in table 1.2. Discussion, salt dissolve faster at 80 degrees Celsius as compared to 30 degrees Celsius. Common sense, right? So if it's hot, it dissolves faster. So the solubility of salt in water increases as the temperature of water increases. Conclusion, as the water temperature increases, the time taken for the salt to dissolve in water decreases. the hypothesis is accepted. So you see, conclusion, we always link to hypothesis. So hypothesis just now, they said the higher the temperature, the faster the salt to dissolve. So now you have to say whether they are true or not true in conclusion. Okay, so this is experiments. Okay, so we already gone through one experiment. Okay, now let's move on. 1.3. This chapter 1, right? We have to go through just like that only. Okay, quickly, because the in terms of exam, it doesn't really ask too much. Okay, maybe they ask some multiple choice only. Okay, accidents can occur at any time in a laboratory, and students must follow laboratory safety rules. So normally you have to do the following. General rules in the laboratory are shown in diagram 1.4. Wear glove to protect your hand. Wear safety goggles to protect your eyes. Wear safety shoes to protect your legs. Wear laboratory coat. Okay, so the white color coat. Okay, now let's move on. Food and drink are prohibited. That means cannot eat or drink in the chemistry laboratory. Keep the laboratory clean and tidy. Obey all warning signs. So like poisonous sign, so something like this. Identify chemical hazards through labels and chemical safety data sheets. So okay, chemical safety data sheet is okay. So if the amount is this particular amount, then it's harmful. Okay, they will tell you. Okay, now personal protective equipment. Okay, let's see. Wearing personal protective equipment such as safety clothing is important in the laboratory as it protects users against any accidents or health hazards. Okay, diagram 1.5 shows personal protective equipment in the laboratory and their function. Safety goggles to protect the eyes from dust and chemical splashes. So the chemicals may splash. When you heat it up, maybe they splash, and then it protect your eyes. Laboratory coat to protect the body and clothing from chemical spills. So accidents may happen. So that's why you have to wear this. Glove to protect hands from injuries, chemicals, or infections when handling chemicals. Okay, so sometimes you are handling virus also, so you have to wear glove, or handling bacteria to avoid infections. Okay, now laboratory shoes to protect the feet from chemical spills, toxic substances, and sharp objects. Face mask to protect the respiratory organs from chemicals in the form of powder or fumes. So to avoid the chemicals to go into your nose. Okay, so the laboratories are also equipped with various safety equipment as shown in diagram 1.6. Okay, let's see. Okay, so we have eye wash to wash and clean the eyes when accident occurs. So if the chemical go into your eyes, you quickly wash it. This kind of thing. And then next one, hand wash to remove chemical substances, oil, dirt, and microorganisms from the hands. Okay, and then safety shower to wash and clean the body when a chemical accidents occur and to extinguish fire on clothing. So we stand by all this. So if your body catch fire, quickly go and shower with water. Okay, so let's move on. Fume chamber. Now, fume chamber is basically there is a ventilation fan on top that will suck the air outside so that the chemical will not come out. The chemical smell will not come out, so they will all suck outside and go to the other places. Okay, so To carry out experiments involving chemicals which are volatile. Volatile means they can change to vapor easily. Volatile. Okay, so volatiles can change to vapor easily. You know, when they change to vapor, then it become a particular smell which may go into your nose, you know. So that's why we do it in a fume chamber to avoid the chemical from coming to the nose of the chemist. Flammable means very easy to catch fire or release toxic vapor. So you have to do it in fume chamber. And now we have fire extinguisher to extinguish fires in the laboratory. Okay, so let's move on. Methods of managing and handling apparatus and chemicals. It's very important to manage and handle apparatus and chemicals in the laboratory with proper methods. Storage of chemicals. Chemicals need to be stored in safe conditions so that they do not endanger the user. Store in safety condition. So for example, you store in bottle. Okay, store in bottle. The different methods of storage are reactive substances. Reactive metals such as lithium, sodium, and potassium are kept in paraffin oil to prevent reactions with moistures in the air. So you put them in oil so that it is not exposed to the oxygen and react with the oxygen. Okay, so because the metals here are very reactive. If you put it in some way that exposed to the air, then they will react and become something else already. Hydrocarbon and organic solvents. Volatile and flammable liquids such as organic solvent and hydrocarbons. Hydrocarbons is what maybe you can imagine now. It is, for example, petrol that you put in the car. That is hydrocarbon. Example of hydrocarbon. So you should know that it is volatile. You go and pump petrol, you can smell the petrol. You can smell it easily, right? The smell of petrol. So volatile. Flammable. Petrol flammable. Okay, so can catch fire easily. So let's move on. Oh. Okay. Okay. So let's see. Okay, just now I talked about hydrocarbons. Are kept in a shady place away from sunlight and sources of heat. So you see petrol, keep in a shady place, away from sunlight. Okay, so the sunlight too hot, then the petrol may catch fire. Okay, so part C. Sodium is stored in paraffin oil. You can see the picture there. Okay, so and you label sodium on the bottle. Substances that easily decompose. Okay, so that means breakdown. Decompose means breakdown. Substances that easily decompose, such as silver nitrate solution, liquid bromine, concentrated nitric acid, and hydrogen peroxide, are kept in a dark bottle. Okay, dark bottle for what? To avoid the light from entering and react and make the chemical react. So light may make the chemicals react. So we don't want that to happen. So we put them in dark bottle to avoid light. Okay, so let's move on. Okay, part D. Substances with yes.
My grandfather called me.
Okay. We look at part D again. Substances with pH values less than 5. pH value less than 5, that means they are acidic. Okay, acidic. So less than 5. Acidic. And more than 9. More than 9 means alkaline or basic. Okay, so let's see the information here. Substances with pH value less than 5, strong acid, and more than 9, strong alkaline, are kept in a special lock cabinet. So strong acid, strong alkaline. So why is this so harmful? Why you need to lock it? Because when you accidentally touch it, it will make the skin burn, so, and then at the end you will see your bone, that kind of problem can happen. Okay, so that's why you have to keep in a locked cabinet. Heavy metals and toxic substances. Heavy metals and toxic substances are stored in specially labeled containers and kept in a locked room. Example of toxic substances and heavy metals are mercury, arsenic, cadmium, lead, and chromium. So very harmful one. So if you ate too much, you will die one. This kind of thing. You die or you get blind. So we have to lock it. Disposers of chemicals. That means you want to throw the chemicals. Cannot throw in the rubbish bin, basically. So you see, disposal of chemicals without following the correct disposal procedure can cause environmental pollution. So for example, in our surrounding, there are factories that throw chemicals in the river. So then the whole area has no water, so they had to clean up the river. So this kind of problem that destroy the habitats of flora and fauna. Flora is the plants, fauna is the animals, and endangers humans. So the proper way to dispose of laboratory waste are, so you see example, hydrogen peroxide. This is an example of chemicals. Solution with a low concentration can be poured directly into the sink. The high concentration solution need to be diluted with water and mixed with sodium sulfite for the decomposition process before pouring into the sink. So must be careful. Not all the chemical can pour into the sink. So for this you need to dilute first. Okay, let's move on. Solid waste. Solid waste such as rubber, plastic, and glass have to be disposed of into special container. Special container, not straight away to the rubbish bin. So special container. Okay, rubber, plastic, and glass. Okay, organic solvent and hydrocarbons. Organic solvents and hydrocarbon waste are kept in special container made of glass or plastic to avoid contamination to water sources. That means and the environment. You have to put in a special container. Don't throw into the river. So don't throw petrol into the river, or don't throw organic solvent into the river. Okay, so you have to keep in a special container. Okay, then other people will handle it. Okay, they will try to find out a suitable way to decompose it. Now, next one, part D. Substances with pH value less than 5 and more than 9, which are strong acid and strong alkaline, should be kept in closed labeled container during disposal. So you have to put in a container, you have to label it. This is strong acid. So these substances can damage the sink and react with water to release a lot of heat and toxic gases. If you throw it to the sink, right, so a lot of gases and heat is released. Okay, so at the end, it's not good to the health. Okay, now E, heavy metals and toxic substances. The solutions are kept in the fume chamber. The residue is tied in plastic bags and put into the container for heavy metal waste and disposed of according to standard procedures. Okay, so the the the, the laboratory assistant will do it. Okay, so you just follow the instructions. Okay, now volatile substances. Volatile waste such as ammonia. Volatile waste means they can easily change to vapor. So then it becomes gas that has a harmful smell or harmful to our nose or lungs. So such as ammonia, bromine, alcohol should be kept in closed container and kept away from heat and sunlight. So we don't want it to vaporize too much. Okay, this is the last part. Emergency management procedure in the laboratory. Okay, emergency management procedure is important to ensure that the laboratory is ready to handle any emergency such as waste spills and fires. Students should respond according to the correct procedure as shown in diagram 1.7. Inform the teacher or laboratory assistants about the accidents immediately. Okay, common sense. Prohibit other students from entering the accident site. Cover the chemical spill with fine sand to stop it from spreading. Use sand, Okay. Clean the chemical spill. Dispose of the chemical spill by following the correct procedure. Okay, so last part. Mercury poisoning. Where is mercury come from? In the thermometer. The thermometer, who knows, it drop on the floor, then the mercury come out, Mercury poisoning may occur when mercury thermometer breaks. Mercury spill should not be touched. Don't touch the mercury. This is because mercury can absorb into the body through the skin. Don't touch the mercury. Okay, so for managing mercury spillage, steps must be taken to inform the teachers or laboratory assistant about the accident immediately. Make the spillage area a restricted zone. Sprinkle sulfur powder to cover up the spillage. Sulfur powder, white yellow color powder. Okay, symptoms of mercury poisonings include nausea, coughing, vomiting. So that means you feel like dizzy, you feel like want to vomit, chest pain, diarrhea, sore throat, difficulty in breathing, headache, eye irritation, vision problems, and increase in blood pressure. I see, it's so harmful. Okay, so finish the theory already.